Now, to put all of this into context, I think it's always good to take an example. So we'll take this example, which was a study published back in 1994 that looked at the effects of looks on wages. Okay, so basically what we're doing again is we're saying wages is a function of looks and maybe some other things, right? So we're really interested in what is the effect of looks on wages. Okay, so in this data set, you're going to find that we have hourly wage information and also some sort of a qualitative measure of looks for people. Maybe this is a scale, right? From 1 to 10 or 1 to 5. But then there are other variables as well. So remember that conceptual model that we were talking about? We want to really think about all of the factors that might affect wages. So maybe we need information on education, so years of schooling, gender, workforce experience, etc. Okay. So in our, we'll look into the data right now, but you're going to find that there are some sort of binary variables. Female would take a value of 1 if the individual was female, 0 if male. So here we just have it binary, but you can code it different ways if you were collecting a different sample, and you can indicate gender. And also you can create other variables from the looks variable, like are the looks below average or above average based on some sort of a metric. Okay, so we can try to look into how to do this in R. Okay, so the first thing you're going to do is you're going to install packages, and you're going to install the Woolrich package, and you're going to load the Woolrich package. Okay, so in the command window, you're going to do the two things, one after the other. And then you can type in help beauty or question mark beauty, and this is going to give you some information on the right hand side about that data set. Okay, so this is telling you that in our textbook, what is the source of this data? Where is this data coming from? And this data is coming from a very, very seminal paper that was written in 1994 by Hammermish and Biddle, which is called Beauty and the Labor Market. Okay. And so the nice thing about Jeffrey Woolridge is that a lot of the colleagues have provided this data for this book, and you can actually replicate those studies if you so wish to. Okay, so anyway, on the right hand side in R, you would see that this is a data frame which has 1,260 observations on 17 variables, and let's try to take a look at what these variables are. So we have wage data, and we have another column probably which says log of wages, and then you have some data on experience, so some data on looks. So looks is basically a qualitative variable, goes from 1 to 5. Is the person a union member or not? So again, remember that because this is a cross-sectional data set, we are looking at individuals at a point in time. So you're collecting or observing all of this information on some sort of a unit. And here the unit is an individual, right? Because we are not talking about, we're talking about looks. So that has to be individual, okay? If the person has good health or not, what is the race of the individual, gender, marital status, where do they live? There's some information on that. And also their education. So maybe all of these factors affect wages, right? So if we really want to isolate, we want to isolate the effect that looks has on wages. We want to control for all of those factors, or keep all of those factors fixed. Okay, so let's take a look at what does this data set look like. So in R, you can type in the command str on the data set, which is called beauty. So if you do str beauty, which basically means show me the structure of the data, you're going to get some output which is going to tell you about the data set. So again, this is telling you this is 1260 observations of 17 variables, and you can actually see the class of those variables, right? So are they numeric, are they integers, and things like that. So here you can see that perhaps the first person in our data set has a wage rate, an hourly wage of $5.73. Of course, this is an old data set, so these numbers are much lower. So that first person has an hourly wage of $5.73. They scored 4 out of 5 on the look scale. They were not a union member, so that's 0. If it was 1, then they would be in the union. They had good health, and looks like that's also a 0, 1. They are not black. This is a female. They are married. They live in a small city and probably work in the service sector and have 14 years of education, right? And these two variables, below average and above average, in this paper are constructed based on, so if looks go from 1 to 5, then below average looks is going to take a value of 1 if looks is less than 3. Otherwise 0, okay? And above average, this variable above average right here, is equal to 1 if looks is above 3. Right? 3 being average looks, and that's how it's created. So notice that for this individual, the first individual that we're looking at, their look score was 4, and that's above 3. So above average should take the value of 1, right? And that's what happens right here. And below average is 0, okay? So that's how this data set is constructed. Now, if you wanted to look into this more, you can actually use, I don't have it written here, but you can basically, in your command window, write down summary, and you can in this manner, you're going to get this output, which is summarizing your data set. So for all the 17 variables, you have some more information on the minimum values, maximum values, median and mean values, and also your first and third quartiles. And notice for example, for your below average and above average dummy variables or dichotomous variables, the minimum value is 0, the maximum value is 1. And also for, if you were to look at looks, for example, this is going from minimum value of 1 to maximum value of 5. Okay, so that's what was described before. And there are a bunch of other dichotomous variables. There are some other commands that might be useful. For example, if you wanted to just look at the first 6 rows of your data set, you can just say head beauty, and this is going to give you the first 6 observations for those 17 variables. Okay. Similarly, you could say tail beauty, and that would give you the last 6 observations for those 17 variables. Okay, so we'd said that this was a data set that has 1260 variables, and that's what we get, right? So this is going from 1 to 1260. This is really nice if you want to really just take a snapshot and look at your data. All of these commands are useful and would be useful throughout the course. Okay, so remember that when we looked at it, we were actually looking at the columns, not rows, but each person, we can say something about each individual when we read across the variables, okay? So person 1 earns $5.73 an hour, is female, has a looks rating of 4 out of 5, and 14 years of education, etc. And maybe even 30 years of work experience, which we missed. So remember that one feature of cross-sectional data is that the ordering of the individuals is arbitrary and unimportant. It really doesn't matter whether the person who goes first in our data set was put last and the person who goes last goes first. It does not matter. As long as we have the data on all those individuals and structured systematically, we don't have a problem. So it's irrelevant who we label number 1 or 2 and so on. Okay, so you can always randomly rearrange the individuals and nothing will be lost. Now, we may come across some cross-sectional data sets that might be experimental, right? So we talked about that before. And these are important data sets because sometimes we are able to assign individuals into treatment and control groups for our experiment. So if we were to let's say try to understand if taking antidepressants what's the relationship between taking antidepressants and happiness, we could think about two sets of people. Hopefully, they have the same score on mental health, and we can basically say that let's give people in group number 1 some antidepressants, and in group number 2, let's give those people a placebo, right? And then we can see if there is a marked difference between the happiness levels of people who fell into group number 1 or group number 2, right? And so we can then say whether there was any effect. Okay, so this in this sense, if group number 1 got the antidepressants, that's the treatment group. And if group number 2 got the placebo, this is your control group because they did not get that antidepressant. So you really want to understand what is the effect. And so you're really just doing an experiment, okay? So remember that the example that we took with the beauty data set, this is not experimental. This is actually a data set which is created by passively collecting information on wages and looks and other variables. Okay, so experimental data sets, like I said before, are relatively rare in the